Let us look at the problem 4. Calculate the work required to be done to stop a bicycle of 24 kg moving at a velocity of 6 km per hour. So in this problem we have to calculate the work and mass of bicycle is given and moving at a velocity. So initial velocity is given. We have initial velocity 6 kilometer per hour and mass is also given. Mass is 24 kg and we have to find the work. So first of all we have to change this in SI system. So initial velocity meter per second, so it is given in kilometer per hour, so we have to change it in meter per second. So kilometer just multiply with 1000, this per means divide and this is per hour. In 1 hour there is 60 into 60 minute. When we solve this we get 1.67 and the unit of velocity is meter per second. This is the initial velocity, this is the mass, and we have to find the work. But in this problem here work required to be done to stop a bicycle, stop, so its final velocity become 0, and we know that work done F into D, displacement. But we have to, first of all we can also write F into S. First of all we have to here force means mass into acceleration, and this S displacement we can find the S by using equations of the motion, that is v square equal to u square plus 2a. Here v is given 0, 0 square means 0, and u square plus 2a. First of all find the value of s, then u square equal to 2a. When this u square come this side, then it become minus u, then it become minus u square, this 2a in multiplication, they it come in division equal to s. This is the value of s. This is the value of s. S equal to minus u square by 2a. This is the value of s. So we can find our work by using this formula. Like now we have work done equal to F into S, and force is given. Yes, force is not given, only mass is given 24. So we know that force is given formula force mass into acceleration, and S is minus u square by 2a. This a and a cancel and it become minus m u square by 2, and we have mass 24, and we have initial velocity also. Initial velocity 1.67, initial velocity is 1.67 square by 2. Just solve it. By solving it we can get 33, we can get 33.46 joule. This is the required work done to stop a bicycle of 24 kg, because we know that work done means F into the displacement. But we have only here mass and initial velocity, and final velocity is 0. Just by using this equation we find the value of s. Then we put here the value of s, then this a and a is cancelled and become this. Then again mass is given 24, velocity is given 1.67 and 2. Then just by doing calculation we get 33.46 joule. This is the required work done. Let us look at the problem 5. In problem 5, calculate the amount of potential energy possessed by a stone with mass 20 kg at the top of the mountain with height 500 meters. So in this problem, we have we have here height, mass, calculate the amount of potential energy. We have to find the potential energy, and potential energy, what? Stone with mass of a stone is 20 kg at the top of the mountain with height is given 500 meter. Then we know that potential energy equal to mgh. And what is the mass? 20. And g, we know that if there is not given, then we can use g equal to 10, and height is given 500. So 5 to the 10, and we have 1 2 3 4 4 0 1 2 3 4 0. And potential energy, the unit of potential energy is joule. This is the required potential energy. But we can also write like 10 to the power 1 2 3 4 5 5 joule. Or if we have to convert in kilojoule, so we can also write 100 kilojoule. Just by dividing with 1000, we get in kilojoule. So this 10 to the power 5, this is the joule in joule. And but if we have to convert in kilojoule, just divide with your 1000, then we get in kilojoule. So this is the required answer. This is the amount of potential energy possessed by a stone with mass 20 kg at the top of the mountain with height 500 meter. So let us look at the next problem, problem 6. In problem 6, we have to calculate the work done. Here we have to calculate the work done. When a body of mass is given, mass is 100 kg, is pushed by 50 Newton. Force is 50 Newton. Force at a distance of 5 meter. Distance is given 5 meter. So calculate the work done. We have to calculate the work done. We know that work done means force into displacement. So force is given 50 and distance or displacement is given 5. So our 5 5 are 25 0, and the unit of work is joule. So this is the required work done, that is 250 joule.